Hello, this is Mrs. Shuver. Welcome to Ratios and Rates Lesson 1, page 2. If you have not already watched Ratio and Rates Lesson 1, please stop this video and go back and watch that first. Initially, I was planning on doing page 1 and 2 together, but it was too lengthy. So let's start with this definition. The blank blank can help us determine the better value for our money. And when we talk about money, we're talking about unit price. So let's write that in. Unit price. And unit price is a unit rate. It just deals with money. So we're going to approach this the same way we did last time. We're going to first read the information that we have, and it looks like there's two different sets of information. So a 12-pack of Orange Crush is priced at $3. So that's told us that we have 12 cans, and we pay $3. The next bit of information says a 6-pack is priced at $1.75. So now we know that we have 6 cans and it's going to cost us $1.75. And then finally the question they ask is, which is a better buy? They sometimes call these type of questions better buy or best buy. So in order to do this, just like we did in the last lesson, we're going to find the unit rate, or in this case, the unit price. And when we do that, we generally, whether they give us the information in this order or not, we write the money on top of the amount of things we have. So the Orange Crush would be $3. Again, even though they gave us how many cans there were before they gave us the amount of money, we always, when we're trying to find unit price, because we're looking for the price first, we put the price on top. So we're going to take $3 and divide it by 12. So you can pause this video and find out the value for each can. If you took $3 and divided it by 12, you should have gotten 0.25 or 0 25 hundredths, which in money is 25 cents. And we're going to write per can. Now we're acknowledging that it's the price, because unit means for one, the price for one can. So now let's move on to the information that we're given regarding the 6-pack. So the 6-pack, again, because we're trying to find the price, we're going to start with $1.75, and this time it's for 6 cans. So I should have labeled that last time. So 12 cans and 6 cans. And this time when we do that, we're going to get a different number. So go right ahead and pause and do that, please. And as luck would have it, this is what number came up on the calculator. And remember, if you have a calculator at the end of this, if it says 7, that's because the calculator has rounded at the last spot. It realizes that these 6s are repeating, so it rounded at its last spot that it has available. So that doesn't look anything like money. So we're going to have to round that using what we call what for the whole number, dot for the decimal, the for the tenth, and h, what dot the heck, h for the hundredth. And we're going to chop the number off here because money is dollars, dimes, and pennies. And then the number back behind, I like to look at it like it's the bossy number. It's kind of not happy it was cut off. So we look at that number, and if this number is 4 or less, it gives the last number that we chopped off a rest. And if this number is 5 or more, it raises the score. So we're going to say that it is 29 cents per can. So now we want to answer the question they ask, which is the better value? So if we look at this, better value in math is always not what is the least expensive. So it doesn't matter regarding the brand, but we want to try the better value. We want to try to spend less money. So the better value is the 12-pack for $3. All right, let's continue on. We're going to look at our next definition, and it says when two ratios are blank, they can be referred to as blank. So when two ratios are equal, they can be referred to as proportional. And once again, what we're doing right now may be review for many of you. You might have covered this in either Mrs. Schuber's class or Mrs. Nord's class. So we want to go into this unit making sure that we have all these vocabulary words under our belt. So next we're going to talk about ways to solve a proportion. So one way to solve a proportion, or to find out if, or to make an equal ratio, is by scaling, and another way is to cross multiply. So let's look at our examples that they have given us right here and see what we can do with those. So this first example, if we look at it, we see 2/3, 2/3, and they've given us both parts of the ratio. And in the second example, we have x compared to 18. And like fractions, we can use our knowledge of fractions to help us. So if we looked at this like it was a denominator, and this also is a denominator, we can tell there's a relationship between these numbers. We could take 3 times 6 to get back 18. So we scaled this up by 6. So now we're going to do exactly the same thing. We're going to scale this 2 up by 6. So if I took times 6, I would indeed get back 18. So I'm going to take 2 times 6. And so now we know what the value of x is. It would be 12. The next example, this time we are given both a numerator and, both numerators for both ratios, but we have a missing denominator. So let's look at what the relationship is between 4 and 16. Well, in order to go from 4 to 16, I could multiply by 4. So we're going to do the same thing now for the 5. We're going to multiply by 4 because it will produce 16, and we're going to multiply by 4 here. And so now we can tell that x must be 20. And if I looked at this, 4/5 makes the same comparison as 6/20. In fact, if you reduce this, the reduced value would be 4/5. Last example, I'm going to give you a moment to try that one on your own. If you said that x was equal to 35, you're correct, because in this case we could scale these both up by 5. And again, we had to key off of this relationship from 6 to 30 to figure out what number to scale up. Our final skill for today is we're going to recall how to cross multiply. And we use something called the butterfly method to help us remember what to do. So we're going to start by doing exactly what this word cross means. We're going to start, and I prefer, personally, it doesn't matter where you start, but I prefer to work with my unknown value first. I'm going to circle that, and that looks a little bit like a butterfly wing, and that means that I'm going to take 3 times x. Then I'm going to build the butterfly body to remind me to put the equal, because we're trying to create 2 equal ratios. And then I'm going to do the other butterfly wing. This is where the cross comes in, and that means 2 times 18. Now you could have written this as x times 3 if you prefer, and you could have written 18 times 2, order doesn't matter, Or for that matter, you could have put the 18 and the 2 together on the first side, the left side, and then 3 times the x on the right side. It doesn't matter. What does matter is that the 3 and the x are together. They must be together. And then that the 2 and the 18 are together. So 2 and 18 must be together. We're crossing whatever is across from each other is what we multiply. So as we look at this, hopefully I'm going to go back to this. Have 3x, and 2 times 18 would be 36. And now we have a one-step equation on our hands. We're going to solve that by dividing by 3 on both sides, and that leaves us with x equals 12. So in other words, 2 is to 3 as 12 is to 18, and we found the same example. We have the same example up above. But let's try this again, and this time we want to make sure we do get the same answers up above, but we want to use this cross multiplication method. So we're going to start out by cross multiplying 4 times x. Again, you could have used 5 times 16 if you prefer. I usually like to look for my variable and do that wing first. The butterfly body reminds us that these are 2 equal ratios we're working with. And then the next wing, 5 times 16 or 16 times 5, whichever way you prefer to write it. And now 4 times x, we're going to just use as 4x. And 5 times 16 would be 80. We now move to our solving step. We're going to build the wall. We're going to divide by 4 and divide by 4 on both sides, leaving us with x equals 20. And sure enough, that's what we had when we used the scaling method. Would you please now try this example using cross multiplication, and you already know what answer you should get from the problem above. All right, so I just want to let you know that you could conceivably put your x on the right side. It really doesn't matter, but the x must be with 6, and the 7 must be with 30. And once again, if we did everything properly, we would have 35 equals x, or you could have said x equals 35. So this is the end of this lesson number 1 today, and I'll see you back here for lesson number 2.